Hello everyone, welcome to my channel. Today I'm sharing the answers of Intext questions of chapter 5 Science class 10th. Question number 1. Did Dobereiner's triads also exist in the columns of Newland's octaves? Answer. Dobereiner's triads also exist in the columns of Newland's octaves. For example, lithium, sodium and potassium constitute a Dobereiner's triad. Also, the second column of Newland's classification has the elements lithium, sodium and potassium. Question number 2. What were the limitations of Dobereiner's classification? Answer. Dobereiner's system of classification failed to arrange all the elements in the form of triads having similar chemical properties. Dobereiner could identify only 3 triads from the elements known at that time. Question number 3. What were the limitations of Newland's law of octaves? Answer. Limitations of Newland's law of octaves were: first, the law of octaves was applicable only up to calcium, which were lighter elements, as after calcium every 8th element did not possess properties similar to that of the first. Second, Newland assumed that only 56 elements existed in nature and no more elements would be discovered in future. After some time, several new elements were discovered whose properties did not fit into the law of octaves. Third, Newland adjusted 2 elements in the same slot, but also put some unlike elements under the same slot. For example, cobalt and nickel are in the same slot and these are placed into the same column as fluorine, chlorine and bromine, which have very different properties than those elements. Use Mendeleev's periodic table to predict the formulae of oxides of the following elements. Answer. First, the element potassium is in group 1 of Mendeleev's periodic table, in which the general formula of the oxides of elements is R2O. Therefore, the formula of oxides of potassium will be K2O. Second, the element C is in the group 4th of Mendeleev's periodic table, in which the general formula of the oxides of element is RO2. Therefore, the formula of oxide of carbon would be CO2. Third, the element aluminium is in the group 3rd of Mendeleev's periodic table, in which the general formula of the oxides of elements is R2O3. Therefore, the formula of oxide aluminium will be Al2O3. Fourth, the element silicon is in the group 4th of Mendeleev's periodic table, in which the general formula of the oxides of elements is RO2. Therefore, the formula of oxide silicon will be SiO2. Fifth, the element barium is in the group 2nd of Mendeleev's periodic table, in which the general formula of the oxides of elements is RO. Therefore, the formula of oxide of barium will be BaO. Question number 2. Besides gallium, which other elements have since been discovered that were left by Mendeleev in his periodic table? Answer. The elements which have been discovered that were left by Mendeleev in his periodic table are scandium and gallium. Question number 3. What were the criteria used by Mendeleev in creating his periodic table? Answer. When Mendeleev started his work, only 63 elements were known. He tried putting the elements in order of their atomic masses. He also examined the relationship between the atomic masses of the elements and their physical and chemical properties. Among chemical properties, Mendeleev focused on the compounds formed by elements with oxygen and hydrogen. He selected hydrogen and oxygen as they are very reactive and formed compounds with most elements. The formula of the oxides and hydrides formed by an element were treated as one of the basic properties of an element for its classification. He then took 63 cards and on each card he wrote down the properties of one element. He selected the elements with similar properties and pinned the cards together in order of their increasing atomic masses. Question number 4. Why do you think the noble gases are placed in a separate group? Answer. Noble gases are very unreactive. So they are placed in a separate group, that is, zero group. And also they are very rare. Second, position of isotopes. As the isotopes of an element have the same atomic number, they should occupy the same place in the periodic table. Third, position of anomalous pair. The position of anomalous pair of elements, that is, pair of elements in which the element with higher atomic mass precedes the element with lower atomic mass, is also decided. When these are arranged in order of the atomic numbers, they occupy their natural places in the periodic table as shown in the following table. Question number 2. Name 2 elements you would expect to show chemical reactions similar to magnesium. What is the basis for your choice? Answer. Beryllium and calcium are the 2 elements which will show similar reactions to magnesium because beryllium and calcium belong to the same group of the periodic table as magnesium. All of these will have same number of electrons in their outermost shell. Question number 3, part A. Name 3 elements that have a single electron in their outermost shell. Answer. Lithium, sodium and potassium. Part B. Name the 2 elements that have 2 electrons in their outermost shells. Answer. Beryllium and magnesium. Part C. Name 3 elements with filled outermost shells. Answer. Helium, neon and argon. Question number 4, part A. Lithium, sodium, potassium are all metals that react with water to liberate hydrogen gas. Is there any similarity in the atoms of these elements? Answer. All these metals have 1 electron in their respective outermost shell. Also, all these elements of group 1 form basic oxides. Part B. Helium is an unreactive gas and neon is a gas of extremely low reactivity. What, if anything, do their atoms have in common? Answer. The outermost shell of the atoms of helium and neon are completely filled with electrons. Therefore, they are extremely unreactive. Question number 5. In the modern periodic table, which are the metals among the first 10 elements? Answer. Among the first 10 elements, only 2 elements, lithium and beryllium, are metals. Question number 6. By considering their position in the periodic table, which one of the following elements would you expect to have maximum metallic characteristic? Answer. Maximum metallic characteristic is found in elements on the extreme left side of the periodic table. Out of the above given elements, beryllium will have the most metallic characteristic because it is on the extreme left side of the periodic table. Tell me pretty lies, look me in the face, tell me that you love me, even if it's fake.